And if there are learners in this group, then to them I want to say that you are the special guests today. Mr. Nambani is actually focusing on the fact to help you. So Nkosi, my great appreciation, sincerely so, and best wishes to you. I see there's Mepe Nene is coming in. I know some of these teachers, and enjoy it. And once again, thank you very much. I'm going to be silent from my side, but I am going to attend the whole class. Thanks a lot and best wishes.
Thank you very much, Henry. I will start in a couple of minutes. Just a kind reminder, everything will be recorded. So the video definitely should be available on our Academy Facebook page, as well as the Facebook page. So now I'm going to start the lesson with a very small introduction of exactly who I am. So the easiest way of doing that, it's for me now to write my name in full so that each and every one of you can now be able to pronounce it the right way. So now the name is Nambani, but now since I've joined the district or even the province now, mostly people now call me Nkosi, and I'm grateful for that. And thank you very much for all the support you've been giving us. We really appreciate it. So now what we wanted to do today is basically to have just an overview of the topic, which is now work, energy, and power. But now, what will be the best way of doing it? The best way of doing it will be now to explain in detail what is work, what is energy, as well as what is power. I will allow questions as we move on, but remember, we are just going to try and explain the basic concepts as to how best can you approach or attend or fully understand now this particular topic, which is now work, energy, and power. It's part of paper 1, but now there's a greater link between work, energy, and power, and now everything else goes now to Newton's second law, to be specific. So now with Newton's second law, the idea is we need now to be able to draw free body diagrams. If from second law or grade 11 we were able now to draw the free body diagrams in full and the right way of doing it, it will assist such that we are able now to understand certain concepts in work, energy, and power. So moving to what is work, energy, and power. I must also admit people here, so I'm doing two things at the same time, but I will try my best.
Mr. Nambani?
Yes, Henry?
I can help from my side if that will be easier for you. So when somebody comes in, I can admit the person. Will that be easy for you?
Yes, Henry, that will help 100%.
Okay. Then I see there's I think it is Meduguele, with a hand. If she wants to ask a question, I don't know if it's an old hand or something.
Okay, maybe we can give her an opportunity to ask something. Meduguele? Meduguele?
Okay, she's quiet
Okay,
now.
she's
All right.
quiet now.
So I will assist from my side. Must I admit everybody that come in, or do you want to restrict the numbers at some stage?
Just admit everybody such that we'll be able to see and check how many tried to join the session.
Okay, fantastic. Okay, I'll support you from my side. Thank you.
Thank you, Henry. Okay, now getting started with the session itself, the question that we ask ourselves first should be, what is now work? So the scientific meaning of work is defined as the product of the magnitude of a force and now the displacement. So it basically says now for us to take of work, we need now to have a force. We also need now to have a displacement. So, but what does it necessarily mean when we say we need a force as well as a displacement? It says now we need to have some form of a formula that we can be able to derive from the definition itself. So from the definition, we are able to say, but now when I look at the definition, already I have a force, which is now a vector quantity. I have displacement now also, which is also a vector quantity. So this allows me now to say, but now I'm going to multiply different units of displacement and a force. At the end of it all, they cancels off now to form what? To form a work that is a scalar quantity. So from the SI units thereof, of which I don't want to dwell much into it, the reason for that is we are not expected to derive formulas, but we are expected to apply the formulas. So it says here, work will be W, which is equals to F multiply now by changing X. So this is a generic equation for what is meant by work. So work is done on an object when a force acts on an object. So for the work to be done, the object now must displace in a certain particular direction. So what basically says here is, if now I have an object of mass m and I pull it now with force F in this particular direction, it means now I must have a certain amount of displacement that the object is going to move. So this x here will be now my distance that the object is moving relative to the force. But we are now in grade 11. The scientific meaning does not necessarily allow us to work with different situations that we are going to be exposed to. So because of that, I decided now to say it's best if we have now a cos of theta. Cos of theta, which will just be an angle between the direction of the force as well as the direction of the motion. So from that equation we have, which is work which is equals to F multiplied by changing X. So this is work. It means now we can introduce the cos of theta. So cos of theta, why? Because cos of theta will allow us to be in a position of understanding exactly the direction between now the motion of an object as well as the direction of the force. I must be able to emphasize this. This angle here can either be theta, can only be 0. I'm not sure what is wrong with my pen. It's responding slowly. So it can either be 0 or it can either be 180 degrees in this equation. That one I need to emphasize. There are a lot of ways of doing all this. But the best thing is, in this equation, theta can only be 0, 180. I am not creating a misconception, but I'm trying to indicate to you that once you use this equation, remember that theta can only be 0 or 180 degrees. So one will ask, when are we going to use 0 and when are we going to use the 180 degrees? I'm going to try and make it easy for us to understand. We use 0. We use 0 if force and displacement are in the same direction. Are in the same direction. Very, very important. And we use now 180. Now, if force and displacement are in an opposite direction. So this is very, very key. You are going to be exposed now to different situations. But once you are going to use this equation here, I want to emphasize this. Once you are going to use this equation, kindly remember you must just substitute 0 or 180. We are going to introduce other different concepts. When we do that, it will be just an add-on to everything that we have spoke about now. So kindly bear in mind that now we only use 0 and 180. And when do we use that? 0 when force and displacement are in the same direction, and as well as now force and displacement in opposite direction. There will be a question that asks which force is doing work specifically when looking at that. So what is key? This is just a general formula. So it being a general formula, it says when I need now to talk of a specific force, I need to specify which force am I working with. So it says the F here can represent any force. So if the F represents now any force, it says to me I need now to be specific. So what do I know? If I am working with frictional force, so it must be WFK depending on the information given, and then FK multiply now by changing X, now cos of theta. So it is important to specify such that we fully know what is it that you are calculating for. You don't lose marks for not specifying exactly which force or which work are you calculating for. So if now I was going to calculate maybe for the tension in the string, it means this force must be my tension, multiply now by displacement, now cos of theta. It makes it easy to fully understand and know when it comes to your angle of theta, the one that you are going to use. Because when we draw the free body diagram, it allows us now to know exactly which force are we working on or working with for that matter. So remember, the PDF of the presentation will be readily available immediately after the session. So if I'm too quick for you, I just want to wrap up everything in the next, at least until 8 o'clock, so that we save data for future purposes. So if I'm too quick, remember you will be able to ask questions in the chat room, or you can even contact me directly, because most of you now do have my contact details. So this is the basic formula and the general formula. So for you to be able to calculate, you need now to specify exactly for which force are you calculating for. Now moving forward, when we are going to work with calculations, it's easy if we develop a strategy, develop a way of answering questions. So the best way is now to identify all forces acting on an object. So if all forces are now acting on an object, it allows me to be able to know and see what is it that I am going to work with. But if I have identified all forces, I need now to be able to draw a free body diagram. So I am going to make a simple situation, or maybe when we get to this part, I will explain that. It says here also, note that work done by all forces acting parallel to the direction of the motion equals to 0. This is the reason. Remember, we said if we have a situation where F is applied in this direction, force applied, and then we have our rough surface. Maybe I should specify also for the purpose of clarity. Then I have my rough surface. Then it says to me I must be able to draw a free body diagram. So drawing a free body diagram, I will have to start with a dot. I will have my normal force applied by the surface. I will have my FW applied now by the object, and then I will have my force applied. Then I will have my frictional force. Then, because of force applied in that direction, and I know that now this will be a direction of motion. What it basically says is, when I want now to calculate anything or work done by each one of them, remember I must now have work done by Fk, which is now Fk multiplied by delta x cos of theta. I must also have now work done by Fa multiply now by changing x cos of theta. I must also have work done by Fn, which is equals to Fn multiply by changing x cos now of theta. Also work done by Fw, which is equals to Fw multiply by changing x cos of theta. So the question should be, if these are the formulas that I have, or this is just the forces that I have identified, which forces are actually doing work? So the forces that are doing work, it will always be forces that are parallel to the surface. So now forces that are parallel to the surface, so forces that are parallel to the surface always do work. on an object. So this is very, very key. So it basically says in most cases, I will be working with forces that are parallel to the surface. That is very, very key. So once the force acts perpendicular, it means now I am going to have a work done, but that work done is equals to 0 joules. The reason for that is, remember we said now cos theta or theta is the angle between the displacement and the force. So if you check my Fn, it's now perpendicular to the surface. It will also be Fw will also be perpendicular to the surface. So what does this necessarily mean? It means now my theta will be equals to 90. So whatever that I have of Fn, it will be Fn multiplied by changing x cos now of 90. So now cos of 90, Fn multiplied by changing x. So now cos of 90 is equals to 0. So everything will be now equals to 0 joules. So that, hence I said in the equation of work, we only now substitute was 0 and 180. I will further explain when is it 180 and when is it 0. But the key thing that we need to understand is the forces that are parallel to the surface are the forces that will always be doing work. So we can easily say, what does it mean now for us to have the net work done? So for us to have the net work done, for an object that is moving at constant velocity, it says now we are going to have equal forces acting on the object itself. So if we have equal forces acting on the object, it will allow us to have now forces cancelling each other. So that issue of constant velocity, it basically informs us that now the work done will also be equals to 0. The reason for that is individual forces that are doing work on the object will cancel each other out. The reason for that is we have equal forces now acting on that particular object. Yes, it is moving at a constant velocity, but majority of people will make a common mistake or a misconception of that. Now it means there are no forces acting on that particular object. So if it's moving at constant velocity, the forces are there. It's just that all forces acting on it, or all forces that are parallel, they now cancels each other because they are of equal magnitude. So the exam guideline also wants us now to explain the difference between negative work and positive work. So I'm going to copy this slide and explain now the difference between the two. So the difference between the two will be, to create space. Now that we understand that only parallel forces are going to do work on an object. So we said we are going now to use 0 when our displacement and force are in the same direction. Then we are going to use 180 when our force and displacement are in opposite directions. So let's go to this particular problem here. So it basically says, for me to work with work done by the force applied, it will be force applied multiply by changing x cos of theta. Now I need to explain the angle at which F applied and the displacement are in. Are they in the same direction? Yes, when I look at FA and I look at the direction of the displacement, I can easily see that now they are in the same direction. So it means for FA, I am going to multiply it with this unknown displacement, but I definitely know that theta will be substituted by 0. Let me write it nicely for you so that we don't create any misconceptions. So cos of theta will be now 0 degrees. And now everything multiplied by cos of theta will definitely be FA multiplied by changing x, and then everything here it's positive. So you will end up with the final answer, which is positive. Now I am going to take one for friction, which is WFK FK multiply by changing x cos of theta. Now Fk is unknown, delta x is also unknown, but now the angle of theta, the angle between the force and the displacement, we can easily see from the free body diagram that now my force is acting in an opposite direction with the displacement. So definitely I am going to use 180. So everything that is a cos of 180, it will give me -1. So I am going to have Fk multiply now by changing x, but now that is negative. So I'm going to say now, but here it means I have positive work, and now here I have negative work. Negative work. So this becomes easy as we calculate for individual forces that are doing work. So I wanted to explain this issue of positive work and negative work, of which now it comes to this particular bullet here. So for positive work, what does it necessarily mean? It means now energy is transferred to the object. It basically says the object is gaining now some energy. If now it becomes a negative work, it basically says the energy is transferred from the object. Basically, it's losing. So in simple English, we can say here, positive work, it basically means that the object is gaining energy. And then for negative work, it's now losing energy. So these are small concepts that you find in the multiple choice. These are small concepts that at times if we don't get them right, we end up not interpreting our questions the right way we are supposed to. So just understand that the positive work, it basically means energy is transferred to the object, and the negative work, it means now energy is transferred from the object. So in simple terms, positive work, the object is gaining energy, and then negative work, the object it's losing the energy. So this is the first section of the exam guideline that we need now to attend to. So these are just the basics in detail. We now have the formula. We now understand how to choose the angle 0, 180, and why now all the perpendicular forces are not doing work on an object. So this will allow us to be in a position that even if I am expected to calculate a work net, that will be easy to do because I have now all the right ways of attending to this particular question. So I decided to break it down into scenarios. So scenario number one, if you check, is basically the same scenario as this one. But where do I want us to go? I want us now to add a question and say, can we derive now a formula, or can we have a strategy of now calculate the net work done? So what does this mean? It says now the net work done is basically now the total work done. So the total work done is basically says sum of all work done by each force. So I can easily see, if I am going to identify the forces that are doing work, then it means, as bullet number one says, identify the force. Bullet number two, draw now a free body diagram. So I'm going to draw a free body diagram. I have my normal force, I have my force applied, and then I have my frictional force, and then I have my FW. Remember, they must be equal, Fn and FW. So it basically says, for me to calculate the net work done, which forces are doing work, we said now it will only be forces that are parallel to the surface. So the forces that are parallel to the surface are this particular two forces. So I can easily say, okay, fine, with this being said, I know that I am going to have work done by FA, which is just FA multiply by changing X cos now of theta. And then at the very same time, I'm going to have work done by FK, which is equals to FK multiply now by changing X cos of theta. So obviously the net work done, it says now work net will be now work done by FA plus now work done by FK. It is true. I've seen in other question papers, in other exams, they will want us now to have the work done by Fn and prove why is it 0, work done by Fw. But with the new trends, we can easily accept this as our net work done on this particular scenario. The reason for that is we work only with forces that influence the object. So in this case, the forces that are influencing the object will be now what? Will be work done by, it will be force applied as well as Fk. Hence, thereof, there is no need now to add the work done by Fn and now the work done by Fw. The reason for that, it will still be 0, and then they will definitely cancel off. So for that reason, we say it is acceptable to work only with the forces that are influencing the motion. But now, I don't think we will be penalized for that because at times we do accept that. But now it will depend on what is it that the examiner of that year is looking for. Or because now the question can also be, are we able to explain in detail while work done by Fn or Fw in this scenario will be 0. So I broke it down into scenarios that you can expect. I did not attach any values because remember the basic lesson is us understanding the concepts, not necessarily doing the calculations thereof. So this is now scenario number 1. Let's go to scenario number 2. Now scenario number 2 is a force acting at an angle with the motion or angle of the motion. What is critical here is, remember, for me to be able to identify my forces, I must be able to draw a correct free body diagram. So I'm going to draw a free body diagram. Okay. Free body diagram. Fn, Fw, F applied, frictional force. But now, what is the problem with this particular free body diagram? There isn't anything wrong. You will get your full 4 marks for it, but it does not assist in terms of knowing exactly which forces are parallel to the surface. Remember, once we have parallel forces, then we know which forces are actually doing work. So the easiest way is, let me resolve this into its components. So resolving this into its components will allow me to have my Fn, to have my Fk, have my Fw, and then have my FH, which is F horizontal, and also have my FV. And this is basically now from grade 11, drawing the correct free body diagrams. So once this is done, it allows me to know that definitely the forces that are going to do work here will be FH and will also now be FK. So I'm not going to dwell much on how to calculate FV, how to calculate FH, as things that now you should have done fully in grade 11. If you are not fully confident with that, then go back to grade 11, practice a few Newton's laws of this kind of a scenario, then you will be able now to fully identify forces as well as know how to calculate that. Because why do I need to know the value of FH? I need to know the value of FH because I am going to need that to say FH must now be delta X cos now of theta. Is it now parallel to the direction of the force? That will be depending on the information that is given. But that is key because already it says to me, I know I need to have a information about now FH. Then I can easily now add FK, which will be just FK multiplied by changing X cos of theta. Then work net will definitely be work net is equals to work done by FH, work done by FH plus now work done by FK, full 100%. Now, because we have extra forces here, Fn and Fv, it basically says if I was going to add work done by the perpendicular forces, it will be now work done by Fn plus work done by Fn plus work done by Fv plus now work done by Fw. That is now if I intended now on having all the forces that are doing work. But I definitely know that these forces here will fall out. The reason being they are perpendicular now, perpendicular to the surface. That is very, very key. So once we have now perpendicular forces to the surface, it allows us now to know that the work done on those or work done by these particular forces are going to be zero. Hence now the only forces that will influence the motion or the value of work net will now be FH and FK. What happens in a situation of having an inclined object? So if you see here, is basically everything we did in Newton's laws. We just introduced now the concept of work. But it's important that I chose the scenarios in such a way that you know that it is applicable in different types of situations. But the key principle is identify the force. After identifying the force, draw a free body diagram. Identify the ones that are now parallel to the surface, and once they are parallel, then you'll be able to know exactly which forces are doing work. So in this case, we have an inclined plane. So in an inclined plane, this is the situation. We are told that there's a force applied in that direction, upward direction, and then a friction down the slope. So still, I will be able to get a maximum max if I draw now this free body diagram. But my advice is decide on one. Even if now I used a dotted lines here, decide on one, because the best one to draw according to the information that is given, it's you have your slope. Up the slope, we have now our force applied. We also have, let me make it shorter. We also have our FK, and then F normal is perpendicular, F normal, and then our FW is always downwards. You will be able now to get your maximum max. But does it assist in terms of getting the maximum max when I'm going to perform a calculation? It doesn't, because remember, in an inclined plane, I also have now the components of FG or FW in this case. So I am going now to draw or have my object in a inclined plane, such that I know that which forces are going where. So I'm going to have my force applied, have now my FK, have my normal, and then have my FW perpendicular, and then I must also have FW parallel. Is it easy now for me to identify which forces are doing work? Yes, it's easy, because now I know the forces that are parallel to the surface. So by so doing, everything becomes nice and easy. Everything becomes clear for me to be able to understand exactly. Because now, if I was told that this is the direction of the motion, and then I was told this is delta x, it will be easy for me to see that this force, it's in the same direction as displacement, so it must be cos of 0. Then if I look at Fk and Fw parallel, they are in an opposite direction with the displacement. So it means it's easy for me to pick it up that is going to be 180 and 180 for Fk as well as for Fw parallel. So this concept of breaking it down into components allows us to have a better understanding, a clear indication of which forces are doing work. So the forces that are doing work, remember, I will emphasize again, is the forces that are parallel to the surface. So once we get that right, everything will become easy, because even if you check here, the information that is given is, if we want to calculate work net, it will be work done by Fg parallel and then work done by Fk plus now the work done by Fa. And then if the object now moves at a constant velocity, remember the forces cancels out, the F net becomes 0, so it means the work done on the object will be now 0. So it becomes very, very easy once we know fully how to calculate each individual force. So kindly go back to grade 11, do more of work as a part of Newton's laws, as part of revision. And once you understand this calculations relating to inclined planes for Newton's laws, everything on this section of work will definitely become